So question number 10 represents anything where we're looking at a maximum or a minimum. In this case, we're literally looking at throwing something where you're tossing a coin off the bridge, it goes up, and then it splashes down into the water below. Okay, and they've given us the equation. We don't actually need to type in a table in Desmos and generate it. It says that the distance of the coin in feet above the water is modeled by this equation, where t is the time in seconds. And if you're having a little trouble with the notation, you'll notice that d of t is normally where our y would go. So we can say that this is really more of a y value, right? Distance is going to be our y. And then these values, these t's, are where our x's are, aren't they? These are where our x's would typically go. So x is going to represent our time in seconds. So if you draw out the shape that you would expect it to make, an up and down shape as you throw something out into the water and then it splashes back down, you'll notice that the greatest height of the coin is going to be at the very top where it stops going up and then starts heading back down towards the water. So we want to find the highest point, the point where it gets the highest on our graph. Okay. So if I look at Desmos, I typed in the equation that it gave me. I didn't even have to change from d of t notation. It just left it the way it was. And this is the equation I got. Now I can zoom in a little further to help myself. And what I'm looking for is what's the highest it ever reached. If I click anywhere in the center here, it'll tell me the point that is at the vertex. And we can see that the vertex is 3 and 256. 3 and 256. Okay, so we have these two numbers, 3 and 256, but which one is the height of the coin? The 3 or the 256? So we have a 3 and a 256. We have to decide which is which. Now, 3 is in the x position and 256 is in the y position. Okay. So we have to decide, are they talking about x or y? Do we need the x value of this or the y value of this? Well, if we're talking about the height of the coin, height is going to be how far up or down it was, right? So we're going up or down, and up or down is always going to be our y. We can also tell because it says the distance of the coin above the water, and we want to know how far the coin was above the water at its highest. So the number of the two that we need of these, this means that at 3 seconds, it was at its highest point of 256, and our greatest height is going to be 256, right? So of the two that we need here, we need up and down, or our height of 256. Okay, so 256 is the one that we need. Let's see if I can adjust this a little bit. Apparently not. So 256 is the one that we want of the two. Now, how much time will it take for the coin to hit the water? Well, the coin would go up and then back down and then hit the water here. When we're talking about t, or time, we said the time was x. That's how far out it is, or left and right. So we go back over to Desmos, and we see, oh, here's where it goes up, and then here's where it hits the water. The ground or the water is always going to be represented by the x-axis, and we know it hasn't been 0 seconds. It's another way that we can tell. So 7 seconds is how much time has passed since it was thrown off the bridge, up into the air, and then down into the water. So we want our x value for hitting the water. So y is always going to be the highest point, and x is always going to be when it's back to the ground. Okay, so that would be 7 seconds. Again, You want y for the highest point, and you want x for when it touches the x-axis.